Hi, my name is Ashley Johnson. This is my lesson plan, my sections 1 through 3. My lesson plan is around a science standard for 3rd grade. I will be teaching a 3rd grade STEM class this fall, so this was a good opportunity to practice this skill for maybe a real lesson plan. The science standard I chose was the one that states that students will represent data in tables and graphical displays to describe typical weather conditions expected during a particular season. And one good thing about NGSS, or Next Generation Science Standards, which are the ones that Arkansas has adopted this year, they already have math and literacy standards written in to integrate with them. And one of the math standards included with this science standard was this one, to measure and estimate liquid volumes or masses using standard units, and then add, subtract, multiply, divide, one-step problems with those volumes or masses. So the objectives that I wanted to achieve in this lesson plan were to have the student be able to measure precipitation, because that is a unit in our science for 3rd graders this year. Is earth science is weather and climate. So in this lesson we will be concentrating on weather and be saying they'll be able to measure precipitation using a rain gauge and record it in units of liters, as the math standard would want us to do, in a personal weather observations log. The student will begin the design process to design and construct their own gauge to collect and measure precipitation. So that'll take it a step further as we move down the line. Why did I choose these objectives? First and foremost, and this is written into the standard, is analyzing data builds on previous experience, progresses to introduce. So it takes things that they've learned kindergarten through 2nd grade and prepares them for beyond 3rd grade in the terms of collecting data and qualitative observations. Also, these objectives help hone the ability to accurately use measurement devices and tools and record data appropriately. These are critical skills in science. And also, scientists record patterns of weather across different times and areas to make predictions of what weather might happen next. This was also written into that science standard above. And why is it relevant? Weather affects everybody. It affects everyday life, and many careers are dependent on weather patterns and conditions. So moving on to section 2, student grouping. And I will say, student grouping and the methods and strategies are new to a non-teacher, coming from a non-education background, going to the classroom this fall. This is where I had an opportunity to learn a lot, and I still have learned. I have a lot to continue to learn. So, dealing with grouping. How will I group students for this objective, for this lesson plan? And I chose whole group, small group, and individual. A whole group is an efficient way to introduce and model the content that I want to cover to all students. If they're all in one place and we can all cover the same material right off the bat, we can start at the same place. And small groups, I listed up here that there'll be groups of 4 based on a seating chart. I listed this because in my particular classroom, I have space constraints, and there are only so many ways to move furniture in my room. So students will automatically be grouped in groups of 4 as the way the seating is in my room. So this seating may change according to behavior, because as we know, if you have a chatty Kathy, she won't be sitting by those. We'll try to place her at a different table as much as we can to try to nip that. And then again, they'll be already in groups close to each other, and that'll make it easier for formative assessments. And small groups allow easier assessment of that, of their ability to work cooperatively, and for formative assessment purposes for me. It will be easier to circulate around the room and see large groups or the small groups in action. And then individual grouping for assessment purposes, there at the end, our formative assessment, our interactive notebooks, should be done on an individual basis. When we reach that part of the lesson, that's where I will be able to assess them individually to see if they've had mastery. Moving on to methods and instructional strategies. The methods I chose for this lesson plan are lecture with discussion and questioning, modeling, feedback, cooperative learning, and graphic organizers. Let's talk about why I chose these methods. Lecture with discussion and questioning. Nobody likes to hear just a dry lecture. So by having questions already built in and prepared, and even more information about maybe who to call on to answer those questions, do some cold calls to check for understanding, and maybe a student that I know is struggling, kind of maybe have that in mind as I write the questions. And discussion, let them ask questions, let them state how or rephrase back what their understanding is of the topic. Modeling, actually showing or telling. In this particular lesson, it would be showing how a rain gauge measures liquid volumes, and then showing, explaining the engineering design process so they can begin the first steps, which is defining a problem and to begin research about how to start their rain gauge project. Feedback. During that lecture and modeling process, having a plan to change your plan. So as I try to engage students, if I see I'm having some that are disengaged, being able to switch tracks based on that feedback. And cooperative learning, working together in teams to learn together. And a graphic organizer or advanced organizers to help represent key ideas or concepts visually, and also is an excellent formative assessment tool. So that is my lesson plan, sections 1 through 3 currently. I appreciate the practice in advance of an exciting year.